widescreen television has a diagonal measure of 42 inches. So here's my television. Okay, 42 inches goes this way. The width of the screen is 16 more than the height. So here's my height over here. Here's my width. And the width of the screen is 16 more than the height. So I can replace my W in any equation that I have with an H plus 16. Okay? Determine the dimensions of the screen to the nearest tenth of an inch. All right, what formula can I use to relate these three sides? They didn't give me an equation. If it was area, I would do area. In this case, I'm going to use Pythagorean's theorem connects all three sides, right? So I know that Pythagorean's theorem is going to be my a squared plus b squared equals c squared. So a and b are always your legs that are connected by a right angle. So this would be my w squared plus my h squared should equal my hypotenuse, which is 42 squared. Okay? And then my width, I can replace this with an h plus 16. So I have h plus 16 squared plus an h squared equals, what's 42 squared? You might have to throw that in your calculator. 1,764, yeah. Okay, so we do have a quadratic, but it's not a really nice one. It's not in the form ax squared plus bx plus c, and it's also not in vertex form. It's in kind of a half-factored, kind of half-not-factored form. So we need to get it to be all like linear first with no brackets in order to look at this one. So we're going to take our h plus 16 squared, and we are going to multiply it by itself to get rid of that set of brackets. Okay, don't forget to distribute this out. So it's not just whatever h squared plus 16 squared is. We actually have to have four terms here. So h times h is h squared. Then you have h times 16, which is 16h, and you will get another 16h. So you can write them both out if you choose to, or you could write them out and already combine them. Hey, that's a 32h altogether. Okay, and then what's 16 times 16? How much? 256? Good, yeah. And then I still have my plus h squared and my 1,764. Okay, all I did for this one here was I combined the 16h and the other 16h to get the 32h. Okay? All right, we can still combine some more terms together. This h squared can go together. So I have 2h squareds plus 32h plus 256 equals 1,764. Okay. Still doesn't look quite like a quadratic. How do we like our quadratics to look? Set equal to 0. Good. So let's minus this 1,764 over to the other side. So 2h squared plus 32h minus, and what do you get left there? Is it 1,500 and something? Anybody get 1,508? Okay, perfect. Okay, now, we could do what we did in 4.2. We could try to factor this and see if it works. But factoring will only work if the factors end up being on that factor list are like integers. So we can't get decimals or fractions or anything like that on that list. So that kind of limits what we can do. So that's why we're learning it another way as well. All quadratics can be put into vertex form. They can be put into vertex form. So we can always find an answer for x-intercepts as long as they actually have x-intercepts. Okay? So if we want to change this into vertex form, there are two ways. There is completing the square way, or there is using my cheat method, which is the p equals negative b over 2a. So let's do completing the square. Okay, so to complete the square, and this will be kind of mind-blowing for some of you if it's been a while, what you do is you don't take out the greatest common factor, even if you always take out the a value. Okay, so my a value is a 2. I always take it out, even if it doesn't come nicely out of the second number. Okay, I always have to take it out. Okay, so it's kind of like the greatest common factor, but if it's not actually the greatest common factor, I still pull it out. I only pull that out of the first two terms. So when I pull that 2 out, I would have left an h squared plus a 16h, and I leave my negative 1,508 on the side. Okay, so I only take it out of the first two terms. Okay, and I don't even take out the h. I leave the h in there. Okay, the next step of completing the square is for you to decide what actually makes this a square. Okay, so this has to do with algebra tiles. Okay, and what you really have is you have an h squared tile, okay, or an x squared tile, and 16 x tiles or 16 h tiles. And you're trying to create a square, and you got to figure out what kind of ones go in here. Okay, so I don't know if Mr. Shemko taught it with tiles, but I don't know if you remember this, but this is a ones tile. This is an x tile because it's a 1 by x. And then something like this would be an x by x, so it's an x squared tile. Did he teach it to you with tiles or no? Okay, your textbook from 3.2 will have it with tiles if you wanted to look through it. Okay, and what's happening is you have your h squared tile right here. It's going to be the same as my x squared tile. And then you have 16, oh, I forgot my h here. You have 16 h tiles or 16 of these x tiles. And you're trying to make a perfect square going this way and out this way. So if you have 16 of them, you better put 8 on one side, 8 on the other, right? To make a square. So I would have 1, 2, 3, 4, 5, 6, 7, 8 of those tiles going that way. And I have 1, 2, 3, 4, 5, 6, 7, 8 going this way. And that's creating a perfect square. How many ones tiles do I end up putting in here to complete this square? 64. How did you get 64? It's 8 by 8. It's an 8 by 8 section. Okay? So now he might not have explained it with tiles, but that's what's happening here. You take your 16 tiles and you cut them in half and you get 8. So you divide this by 2 and you get 8. And then you square the 8. So then you square it and it tells you what number you're going to put here. So when we square that 8, we end up getting 64. Now, do we actually have 64 single tiles to put there? No, we're just making it up. We know we're going to need 64, so that's why we put plus 64. But we also put a 64 negatives, and we just kind of hold those on the outside. Because I don't want to change what it's worth. So if I'm going to add 64 of something, I better make sure that I have negative 64 of those same things somewhere else. So it's almost like I'm going to complete the square with these 64 items here, and they're all positives. But over on the side, I'm going to hold on to 64 negatives somewhere over there. Okay? All right. So now what happens is I'm going to keep these first 3 terms in here. And the reason why I'm going to keep these first 3 terms is because those are the 3 that are going to make my perfect square. Okay? This guy right here does not make part of my perfect square. He's extra. He's on the outside. But since this part here only represents 1 perfect square, and I know that I actually have 2 of them, agreed, I have 2 of them. So what happens is I don't just have a negative 64 on the outside. I have 2 times a negative 64 on the outside that has to come up. So I will have a negative 128 out there, along with that negative 1,508 that was already there. Okay, this is lots of information, but we'll practice and practice and practice. Okay, now this was a perfect square here. What was its length going across this way? And what was its width going across this way? And you only read the side. So this is how long? X or H plus 8. What's this one going this way? Right, H plus 8. So what this really is here is these 3 terms make a perfect square. The length times the width is exactly the same. It's H plus H times by H plus 8. So it's H plus 8 squared. okay? And I just have two of them. And then let's put these two numbers together. Negative 128 minus 1,508. What do we get there? What'd you get? I don't have that number on my page. Should be 16,000, 1,600? 1,636? 1,636? Who agrees with them? Okay, good. All right. All right. So that's how you get it into perfect squares. Or sorry, that's how you get it into a vertex form. Okay, so this is how you get into vertex form. This is one way. We can do the other way as well. So I'm gonna flip back and forth. When I do the next example, I'll do it the other way, and then I'll come back to this way as well. So now you're in vertex form, but we haven't solved anything. The whole point of this, though, is we need to figure out what h we have here that's going to make this whole thing equal to 0. So now is where those steps where you have an A, a P, and a Q, and we'll go through those steps of how to get this isolated. So you would add 1,636 to both sides, and you'd be left with 2 with an h plus 8 squared equals 1,636. Then you would divide by 2 on both sides. So you'd still have your h plus 8 squared, but over here you'd have 818. I think the first question in your textbook when you go to do the assignment starts this way and asks you to solve for h. So you need to envision that you've already done, the square's already completed, you already have vertex form, you already moved your p over, and you already moved your q over, and you already divided by a, and you're already at this step, okay? So once you're here, what's the next step? Square root, okay? So you got to square root both sides, and this is where I put the plus and minus. Whoops, I'm going to try to sneak it in here. I usually put a plus and minus here on the outside of the square root. Okay, because if you introduce it, you have to put plus and minus. On this side, the square root and the square nicely cancel, so you have an h plus 8. On the other side, you have the square root of 818. Now, is this a perfect square? So throw into your calculator, is it a perfect square? No. Okay, so I'm going to leave it like this as the plus and minus of the square root of 818. I will show you at some point how to reduce these radicals, because sometimes radicals, for example, something like a square root of 12, you should be able to reduce it to 2 square root 3 at some point. So remind me, I'll also show you that at a later date. For now, we're okay with this. Okay? Next thing, we're trying to get h by itself. I know this equation looks a little bit different because it's got a plus and minus and a square root, but how do I get the h by itself? Subtract 8 from both sides. Good. And there is no correct way of writing the second side, but more often than not, they don't put the plus or minus first. They put the integer first, so negative 8, then the plus or minus goes afterwards, the plus or minus 818. Okay, so you could throw this into your calculator as 2 answers. Okay, there will be a minus answer and a plus answer. I always, even though it's plus and minus, that's the order that goes in, I always write mine like this if I remember to, because this one over here with the minus should be smaller than the one with the plus, and then I think of a number line. So throw it into your calculator. Negative 8 minus the square root of 818. What decimal do you get to the nearest? They went to the nearest 10th. Or they asked for the nearest 10th. What do you get? Negative 36.6. And what would you say about that if it's in inches? It's extraneous, right? Because you can't have a negative length. So this right here is an extraneous root. Okay, on this one, you have h equals negative 8 plus the square root of 818. And what do you get there? 20.6 inches. Good. So 20.6 inches. Now, if they wanted the dimensions, we have the height. But how do we find the width? Well, the width was the height plus 16. So this is one of those ones I was talking about in the last lesson, where you're going to end up getting an answer that looks like this other extraneous root. But you have to show why is it positive? Where did you get it from? You can't just switch a negative to positive. Here it mathematically works that it's positive because you've used the information from the question.